recap what we did on Thursday, and then finish up these notes. So sequences. Sequences represent patterns. Sequences represent patterns. They can be illustrated in two ways, either with a list of numbers or as an equation. If it's given as an equation, that's called a rule. That's just a rule for the sequence. So when we evaluate sequences, evaluating sequences is either identifying numbers in a pattern or plugging in numbers into an equation. So when they say A1, that means first term. Take 1, plug it in to the equation, work it out. So evaluating lines up with IXL-CC3. This is IXL-CC3. That's evaluating. So you have notes sitting there from last week, Thursday. So there are two types of sequences. When you are adding or subtracting, that is called an arithmetic sequence, when the numbers are adding and subtracting by the same value. Geometric sequences is multiplying or dividing. However, dividing is represented as a fraction. So you see a fraction, that means division, but we have to use a fraction to represent it. So before we stopped on Thursday, we wrote equations for arithmetic sequences. That lines up with IXL-CC6. So you're given a pattern of numbers. Identify the first term, first number, and the common difference. What are they adding or subtracting by? Figure out the first term and the common difference. Substitute the values into the formula. Simplify the formula. And then use the formula to evaluate. Sometimes you will have to do that, sometimes you won't. It depends on the problem. So this lines up with IXL-CC6. This will line up IXL-CC6. So we did 2 examples of this on Thursday. 1 and 2. So now we're going to write formulas for a geometric sequence. So our last 2 examples will be for a geometric sequence. So for a geometric sequence, remember, geometric sequences, you're multiplying or dividing by the same number. So the first step is still the same. Identify the first term and the common ratio. First term and the common ratio. So for example 1, here's our set of numbers. So your first term is simply the first number that you see, 0.4. So the common ratio is what is each number being multiplied by. Now, for decimals, or any number for that matter, it might be a little difficult to figure that out. So to find the common ratio, the easiest way to do it is to take the second number divided by the first number. Take the second number divided by the first number, and it will tell you what it is. So negative 1.2 divided by 0.4 is negative 3. So each of these numbers are being multiplied by negative 3. Yes, multiplied by negative 3. So that's your first term, that's your common ratio. Any questions before we continue? you have a question you need to ask, it's put up or shut up time now.
So for example, 2, will you want the combination of
Example 2? Talking about that?
yeah, first one, just be sure.
It goes for all of them, but the second example is not -3. That would be -5.
Oh, yeah.
That's for example 1, that's -3. Example 2 wouldn't be -3. The process is the same, but the actual number is not going to be the same. So you have to understand the process. It's not going to be the exact same number. So the first term is simply that, the first term. It gets the common ratio. You take the second number divided by the first number. Second number divided by the first number. That will tell you what everything is being multiplied by. That's the first step. Second step. Substitute those values into the formula. So this is the formula for a geometric sequence. So A1 represents the first term. R represents the common ratio. So, since the first term was 0.4, you have AN equals 0.4. R is the common ratio. So since R is -3, times -3 raised to the n-1 power. They're literally plugging the numbers in. Everything else stays the same. AN doesn't change, n-1 doesn't change. So the only two things that change are A1, first term, and R, the common ratio. So that's step 2. Any questions? Step 2. So step 3 tells you to simplify the expression. The beautiful thing about this is there's nothing to simplify. That's your answer. There's nothing to simplify. Nothing to simplify. So steps 2 and 3 take care of themselves. There's step 1. Steps 2 and 3 take care of themselves. The optional step 4 is to use the formula to evaluate. This depends on the problem. Depends on if they ask you to do it. I know your IXLs ask you to do it for some of them, so that's why we're practicing. I know when you take your test on Thursday, it will ask you to do it. So let's assume that they ask you to find A6. So A7. Find A7. So again, this re-practices how to evaluate a sequence. So that means take your formula, I'll write it correctly, and take the number 7 and plug it in. So now all you're doing is following order of operations. Parentheses, and then exponents. So 7 minus 1 is 6. -3 raised to the 6th power is 729. Which gives you 291.6. So again, step 4 is optional depending on if the problem asks you to do it. But we're doing it because I know your IXLs will ask you to do it. Your unit test is going to ask you to do it. But it's not that difficult, you're just plugging in a number and solve. Any questions on example 1 before we do one more example? Hopefully those of you are at home, you are taking your notes, you are processing, you are asking questions. You are allowed to use your notes when you take your test on Thursday, but it's not going to help you if you don't practice. All right, so example 2. Last example. Write the formula for geometric sequence, -2, 10, -50, 250, etc. So we're doing the exact same steps as before. So the first step is to identify the first term. So the first term is the first number. To get the common ratio, you take the second number divided by the first number. The second number is 10, first number is -2. 10 divided by -2, -5. So we know the first two parts right off the bat. Any questions before we continue? Not seeing any, not hearing any, so let's keep going. Step 2, put everything into the formula. So we're literally plugging in the two numbers that we had. AN doesn't get touched. A1 is your first term. R is your common ratio. The other two parts don't get touched. And then there's nothing to simplify here. So 2 and 3 are the same set. This is your final answer. So that's your formula. Now, this is what a lot of people do, and this is how people get it wrong. They're going to take -2 and -5 and multiply it together, and they're going to make it 10 to the n minus 1. No, do not multiply them together. They're asking for the formula. This is your formula. Any questions before we finish the problem? So the last step is to evaluate it if we need to. So we're going to do the optional step 4. We're going to find the 7 determinant sequence using our formula. So there's your formula. We're going to take 7 and plug it in. So again, order of operations, parentheses, exponents. So -5 raised to the 6th power is 15,625. Multiply times -2. Negative 31,250. So that's our optional step 4 if we had to do it. How would we know that we have to do it? We would read the directions. We read the directions. Any questions, example 2? All right, so geometric sequences goes with IXL CC7. So now we have done each of the skills and the concepts associated with each IXL. We've done the skills and the concepts for each IXL. So now you can use these notes and you can use the video to help you navigate through those IXLs. Remember, those IXLs are due by the end of tomorrow. Don't wait until tomorrow. Some of y'all got work that you gotta get it made up. So we said